Okay, 2:05. Let's begin. Welcome everyone to MLOps, Machine Learning in Production, Bay Area. Our talk right now is from the great folks at the wonderful Adobe, my favorite companies. Keeps me up at night playing with all your products, cool things, and all the changes. So our talk today is automated monitoring in production for continuous model improvements. And our speakers are Vijay and Deepak. Deepak is a machine learning engineer with 16 years of experience. He has published papers in top peer-reviewed conferences and holds multiple US patents. Currently, he manages a team of machine learning engineers developing multiple products and services at Adobe that are part of the very cool digital experience business. Deepak holds Masters and Bachelor's degree in computer science from a leading university in India. And Vijay has 15 years of industry experience across machine learning and e-learning products. He has extensive experience in developing scalable machine learning and e-learning cloud services right from inception. During his technical journey at Adobe, he's worked in multiple key positions as senior computer scientist and staff data scientist. As part of his current job, he manages a team of machine learning engineers developing core machine learning products, which feed the machine learning insights to experience cloud intelligence services. He holds a bachelor's degree from Indian Institute of Information Technology. Can't wait to hear this. Take it away, guys.
Thanks, Malini, for the kind introduction. Hello, everyone, and welcome to our talk on automated monitoring in production for continuous model improvements. I'm Deepak, and I'll be co-presenting this talk with my colleague, Vijay.
Hi, everyone. Thanks for attending the session. Yeah, what do you do?
We'll start with giving you a brief overview of what our team does and how it fits into the larger picture of various products that Adobe offers. We'll then motivate the need for MLOps, in particular automated monitoring in production for continuous model improvements. For comparison purposes, we'll touch upon how the MLOps space is occupied today with various startups and large companies. And we'll then describe various metrics that we compute in a scalable and automated fashion and how these metrics help data scientists improve the models. So let's start from the top. Adobe's products broadly fall into three verticals. First one is Adobe Creative Cloud, which is products such as Photoshop and Premiere Pro that are targeted to the creative professionals. Second is Adobe Document Cloud, which is products such as Acrobat, PDF, and Sign that target the document processing workflows. Finally, there is Experience Cloud, which are products and services targeted to the marketing organizations. They help marketers do a variety of tasks such as organizing content, optimizing their website, their ad spend, and so on. We are part of the digital experience business. Our organization called Intelligent Services is responsible for building AI ML services for the spectrum of products in the digital experience business. We have products such as Customer AI, Attribution AI, Content Intelligence that cater to a variety of use cases. So Adobe has what is called Experience Platform, which provides infrastructural capabilities and allows customers to bring in data from various Adobe solutions or other CRM systems. Different intelligence services provide AI as a service on top of this data. Our team works on building ML platform, which is horizontal capability that is leveraged across multiple intelligence services. Naturally, we are layered in between the platform and the intelligence service. In the realm of intelligence services, we have products such as Customer AI, which help marketers understand and predict customer behavior. We have Attribution AI, which algorithmically attributes conversions to appropriate marketing channels. We have Content Intelligence, which gleans metadata or intelligence from unstructured content, be it text or images. The thing to highlight here is that we are talking about building AI ML as a service that is sold to customers and not a model that we operate and build for Adobe. So each customer data and model are handled in silo with multi-tenancy, adding further complexity to the MLOps. Here are some capabilities that we have built or are actively building as part of our ML platform. First is Data Quality Service, which computes a variety of metrics about the data and alerts users when there are problems with the ingested data. Second, Model Quality Service computes various performance metrics from the models that are in production and alerts users when there are problems with the model. Both these services leverage anomaly detection to identify anomalies. Contribution analysis aims to identify likely causes for the anomalies in the model performance. And interpretability attributes the model behavior to input features, be it either at a global level or a local level. Finally, the bias detection service identifies unintended bias in data or model. With that, we move on to the primary topic of this presentation, which is continuous model evaluation in production. Currently, in the industry, it is not uncommon that one spends a lot of time and effort in tasks involving data cleansing, model building, ensuring that the model has acceptable accuracy, and so on before deploying the model. However, once the model is in production, the models are not monitored actively. A more reactive approach is used, wherein the models are looked at only when a possibly critical problem arises. By the time the problem is identified and fixed, it may be too late, as the model would have already produced incorrect predictions. Primarily, the model performance degradations arise due to deterioration in the input data quality or shift in data distribution. Typically, the process of identifying the problem is mostly manual and results in a lot of wasted effort. Therefore, it would be advantageous to have a system which not only monitors the performance of the model, but also identifies anomalies in the input data to attribute the source of performance degradation. Further, the number of customers and models per customer that we have are so large that it is infeasible to manually keep track of these performance metrics. Given the scale of the problem, it is not surprising that we see many companies operating in this space, either startups as well as large players. Most of these have emerged in the last few years, and our development efforts were either parallel or predate them. Further, evaluating and finding the right technology that solves your problem at the right price point is not trivial. Moreover, one would notice that the space is quite fragmented. That is, if you need some features from data quality and model evaluation and interpretation capabilities, it means that you're looking at more than one vendor. So there is a lot of effort in terms of integrating with each of the vendors and making sure that the end-to-end workflow is working. For someone who is starting fresh on this, our recommendation would be to strongly consider one of these available players before starting to build something on your own. Moving on to our model evaluation service, it allows performance monitoring of production models over different kinds of metrics like an AUC or a precision recall curve, accuracy, and so on. It generates score as well as ground label or ground truth data distribution, which can be viewed by the data scientist. It also helps people visualize the performance metrics sliced over different features over a period of time, so that one can monitor how these performance metrics are varying by different dimensions of the feature or how they are varying over time. It also allows configuring thresholds on output metrics, which could be used to trigger alerts in case the performance goes beyond the threshold. It also is able to detect performance drops automatically. With that, I'll hand it over to Vijay to talk about the details of this service.
Thanks, Deepak. Yeah, thanks for a nice overview. Let's dig down more on model evaluation and see how model insights are being integrated into the intelligence services like customer AI, journey AI that Deepak briefly mentioned at the start. So this is a high-level overview showing how intelligence services apps gets created and how models are onboarded into the internal ML platform. A customer can create multiple intelligence service app, like they can log into the experience platform, they can create, they can pick the corresponding intelligence services, either customer AI, attribution AI, and then they can create the corresponding apps. So internally, these apps is mapped to the internal model, which are uploaded to the ML platform. And this is done for all models across different orgs and corresponding to each app. And that shows the scalability of our ML platform. So whenever a scoring batch get ingested in these apps, and whenever the ground truth gets available, so ML platform automatically computes the score distribution as well as the performance metrics, maybe the conversion rate, AOC for each batch globally, as well as the sliced over key features. So once these metrics are computed, so these are also pulled automatically by the intelligence service app via REST API. And just to give you a brief idea, our ML platform compute layer is built on Scala Spark-based solution that is deployed on the Azure Databricks. Okay, so once the score batch is processed, one could see the score insight for the latest scoring batch in Intelligence Services portal, which is available on the Adobe Experience platform. As I mentioned, these metrics are computed globally as well as over slicing columns, or you can say slicing dimension or the features. We can think of like the propensity bucket as one of the slicing feature. So with value like high propensity, medium propensity, low propensity. Similarly, other slicing feature could be the scoring bins with equal weight. So here we could see the score distribution with respect to the customer user profile count over this propensity bucket and the score bucket. But this is a very useful insights to the customer, as the customer might want to run a campaign, say to target a people in a given scoring segment, maybe 60 to 80 or maybe 40 to 60. So they can use this distribution over bin to estimate how many people that would be. Okay, so far we have seen, right? So we have seen that the score distribution of the latest batch, but our platform also pursued the distribution and the site for all previous batches, so that can be used and analyzed by the data scientists to compare their model score performance. So we have seen the score distribution and the alias, right? Now let's monitor the actual model performance metric. That is it could be the rate metric, it could be the AOC. In this particular example, it is the conversion rate over time. So just like score distribution, this performance metric also are computed sliced over this key dimension. In this case, it's a propensity bucket. You can see the actual conversion rate as well as the expected conversion rate over these propensity buckets. Depending on the requirement, one could either visualize the global time trend as well as the sliced by the feature value. So these performance metrics are shown sliced by this propensity bucket to make it consistent with the way we display the score inside. In general, the purpose of this model performance tab is to build a trust in the model quality. Right? So these are the just couple of visualization from the intelligence services app, and these are publicly available via intelligence service via intelligence services, and one can go and check out the more detail of these intelligence services and can explore a lot of more details which are specific to each service, like customer AI and attribution AI. They can see the influential factor. They can see what all the important features are there that define the customer journey. All these things are available via intelligence services documentation. So here the purpose is to cover the metric which are very core to the model evaluation platform. As you can see, so we have seen the distribution insight and performance insights on the intelligence services portal, but our ML platform also provide an internal dashboard that provide far more insights to the data scientists and the analysts. Let's look at the higher level overview of the model, one of the model which are onboarded to the ML platform. So internally, the models, the feature, the metrics, all are represented as a DAG, a direct acyclic node. And on clicking of this node, one could see the corresponding time trend or the corresponding metrics. For example, on clicking on the model, we could see the time trend of AOC metric. If there are other metrics like rate metrics configured, people can select, customer can select that metric and see the time trends globally as well as sliced by the columns. So this is the another visualization where one could see the score distribution also by clicking on the corresponding scoring batch data source. And not only we see the average score, but one could see the maximum score, minimum score, the standard deviation, and the total profile count also. So the difference between the earlier score insight, that insight was specific to a batch, but these insights are available across all the batches given a time range. This is another visualization where one could see the score distribution over deciles. As we have seen the score distribution earlier in the score bin buckets, here we could see that the similar score distribution over the 10 buckets, we can say the decile. The difference is again the same. We could see over any time range across different batches. Okay, so as I mentioned that our internal dashboards provide far more insight that are exposed externally. For example, a data scientist could use our internal dashboard to compare the score distribution over deciles for any given two batch, right? So this is quite useful, like to see if how model is performance across batches. So let's switch our gear a little bit from the standard metric like AOC and rate to slightly more complex metrics. So far, we have seen the standard metric like AOC and the rate. However, there is something more our platform offers. One can define their own custom metrics like, let's say, approval rate or false positive rate, depending on their corresponding use case or the project. Let's look at this concrete example. For one of our internal project, which is the fraud detection project, our team wanted to monitor some custom metrics like approval rate, auth rate, recall rate, along with the standard metric like AOC, which are available by default whenever our model is onboarded to our platform. So let's look at the custom metric now. Yeah, as one could say, like one can define the custom metrics like this approval rate in terms of the custom expression, which can be done via REST API or through our internal dashboard. Here you could see the approval rate is defined in terms of true negative, false positive, and true positive. Similarly, other metric can also be defined. Once these metrics are defined, so whenever a new batch gets ingested, these metrics will be computed by our internal platform, and one could see the time trend for this. This is quite a useful feature because every project had their different requirement and they want to monitor a different metrics for their models. So far, we have covered the major functionality of our platform, like score inside and score inside the model performance insights. Now, let's briefly touch upon the challenges we faced and the optimization we have done to efficiently compute these metrics and the score insight globally, as well as the uh, sliced over the different features and the different dimensions. Okay, so just to give you a snapshot of the challenges and optimization, let's look at the standard AOC metric computation. So, and the same challenges and optimization we have done, challenges we faced and the optimization we have done for other metric also. So for computing the AOC globally, we have looked at the Spark ML implementation of binary classification metric that compute AOC given a set of RDD. You can say the RDD is a data set where each row has minimal score and label, right? So once you have the data set of that RDD, so binary classification metric compute AOC for that. But what if like with we want this AOC to be computed over all possible enumeration of a feature, right? So what are the challenges? So what we would need that, like we need to filter out for each such slicing feature and each such feature value. For example, if the slicing column or the feature is a country, then we want to filter out say country equal to US, then we'll get a different RDD, and then that RDD would be passed to the existing implementation of the binary classification matrix to compute AOC. As you could see, this is not quite efficient. Think of the scenario where you have like multiple slicing feature. One could be country, one could be marketing area, one could be a product area, and one could be the channel mapping, and so on. And for each feature, there could be a number of feature enums. So you could imagine the cardinality of all these features, and you could see that how many filtering we have to do, how many RDD we need to create, and how many calls to we need to make to the existing implementation of binary classification metric. So what's the workaround here? So what we have done, since our main use case was to compute all these metrics and the score insight over different feature values. So what we have done, we have updated the existing binary classification metric so that it could incorporate not only the score and label, but as well as the feature and the corresponding value. So as a result, so what we could do, like with a single call, we could pass this transform RDD where where we transform the existing RDD into this new format like feature value, score, and label, and we can pass to the existing implementation and compute AOC in a single go. And as you could clearly see, the advantage is like you don't have to, it doesn't depend on the cardinality of the features and the number of slicing dimension. Okay, so a picture is worth 1,000 words. So let me take a concrete example. So this is the sample RDD. You can say the each row, there are certain columns like ID column, country, product, score, and conversion level. These are the minimum set of columns. And you can imagine the country and the product as a slicing features. And each this slicing feature has, let's say there are two values for country, US and India, and the product, there's the Photoshop, After Effects. So in order to use the existing implementation, one has to filter out and create a forward RDD based on this feature value, and then make a call to the existing implementation. So with the updated implementation, so what we do, we take the original RDD, we transform this RDD into a RDD of tuples, where you could see the tuples as a feature value, the score, and the label. You could see the score and labels are repeated, but that's the cost we need to pay in order to make compute all these metrics in a single go. So once we have transformed this RDD, we can pass this to the updated implementation that take RDD in this format. It has a feature, feature value, a score, and label. And internally, we have done a lot of optimization to the existing implementation. As a result, we get all this metric value per feature in a single go. All good. So we are monitoring model performance. So we are monitoring the score inside. Excellent. But is that sufficient? Right? At some stage, we know that model performance is going to be dropped or it is going to be changed. Then what action should we take? Wouldn't it be better to do some causality analysis to find out the root cause of this model performance or the model performance degradation with respect to the input data quality? It could be the valid rows, it could be the, if the data is corrupted or there is a shift or there's a drift into the data, right? So that's the next step we are heading towards. Let me briefly touch upon the causality analysis. So the causality analysis make use of data quality. We have, as Deepak mentioned, we have a lot of services which are already developed and which are in under development. So the causality analysis make use of this data quality and model evaluation service to detect anomalies in input and output metrics. So let's say there is a dip in the AOC, which is the output metric. It could be the AOC, it could be the another output metrics, for example, engagement index, right? And we can attribute this corresponding dip with a corresponding input data quality metric. For example, it could be the data quality metric could be the valid rows. For example, the raw data quality from which the model is trained upon, there is a anomaly into that data or the data is corrupt, right? So the data quality and the model evaluation service result in time series of various metrics. So one could use input and output time series data to find out the anomalous data point using anomaly detection algorithm and attribute them to one of the two aspects. So one is input data quality metrics like value rows, other is the input data distribution. So in a simplistic example, one could look at the mean and the standard deviation of the data, just ignoring the time series aspect, and categorize these data points that fall outside of the mean plus minus 2 standard deviation as an anomalous. So this is very simple implementation, but one could think of another complex and another more sophisticated algorithm to find out the anomalies. So the basic idea is look at the performance metrics, check if there is a dip or the degradation, and correspondingly try to find out the anomalous behavior in the input metric. All right. So we have covered how model performance can be monitored via score insight, performance metric like AOC, as well as the custom metrics. And we briefly touched upon the causality analysis as well. So let's look at some takeaway from this session before we open up for the question. The model, as you know, that model deployment to production is half work done. So one should have a automated, one should automate this model monitoring, either leveraging the internal solution or the third party integration, right? So as Deepak mentioned, we should always look for the what is currently available outside before actually reinventing the wheel by developing the internal solution. So one should have one major most often all these models customer have multiple models across different projects and different teams, right? So once the scalability is another important factor that should be considered while finalizing on this monitoring solution. So and also definitely that solution should have a provision for automatic alert to detect model performance degradation and a notification system. Finally, one should always think of like how to attribute this model performance with the corresponding input metric, right? So the way we are doing the causality analysis. Okay, so that's all for the today's session. Thanks a lot for attending the session, and we are open up for the question.
Okay, I don't see any questions. Come on, audience, you must have some questions. Can you give us, Adobe always has these wonderful resources, and I'm looking to see if there's like a learning path that you could recommend for people to come up to speed and get, deeply, a deeper understanding of this. Could you point us to some of your resources and a nice learning path?
Unfortunately, there are no external resources. This is something that we had done internally as part of our platform. And from Adobe Experience Business, it's the target persona that we are selling this to is the marketers and not the data scientists as such. So there are no external facing resources as such. We do have a whole bunch of resources internally that is accessible to our data scientists for them to leverage this system and make use of it to improve their models.
Okay, so you said the target is for the marketing personnel.
Right. So the intelligence services that we are building, they are targeted to the marketing persona.
And so as easy to use as possible, is that what you...
Right.
So I do have a question here. Can you briefly talk about infra, which I assume means infrastructure, used by production services to share metrics data with internal ML platform? Thank you for your question. Should I read it again?
Sure. No, let me take a stab on this. So as I mentioned, like, so our core like ML platform, the compute layer is built on top of Spark and Scala solution, which are deployed on Azure Databricks. So that is the core part, which computes, which reads the data from various sources. In our case, it reads the data from Experience platform, which is the the hub for all customer data. So we read the data, and then we read the ground truth, and we join the data, and all this computation and the metric computation happens on this compute layer. And the communication between these metrics and to the intelligence services which are consuming this metrics are done via REST API. So, and that is deployed as an Python-based, the Flask-based web service, which are deployed on Azure infrastructure as an app service. So that is another layer which we call it as the API layer. So that is one thing. And what else? Yes. So Deepak, you want to add on something? If I'm missing. Yeah. Okay. So yeah. So these are the high level the infrastructure we can say that this there.
Thanks.
Okay. Thank you.
Gansan, I'm not sure if I'm pronouncing your name correctly, but the person who asked the question said thank you. Is Deepak frozen, perhaps?
Yeah, it's look like no issues. Yeah, sometimes it is happening with the Chrome browser.
Yeah. He's probably just
no
dying
problem. I can take
to weigh in. Oh, I think he's back.
Yeah, he's back. Yeah,
did you want to add anything, Deepak?
Yeah, no problem. I can take up. I hope that made it clear. Yeah.
I think so, because we're not getting any follow-up questions, and that's very helpful. And I don't see any more questions. So I'm going to thank you for your time, and thank you for sharing your incredible experience and these great products with us, and keep up with the innovation. Where's the focus now for the next versions?
Yeah. Thanks a lot, and thanks for attending the sessions, and thanks a lot to all the folks who were able to attend our session. So as I mentioned, like the next is like we are looking ahead, for all the other aspect, like the finding out the relationship between the performance, model performance with respect to the input data, quality metrics, which I briefly touched upon, and later on also the work is in progress is like with respect to the model interpretation, right? How model is predicting something which is kind of black magic. So that's another area which we are exploring to come up with a better explanation, right? So yeah.
Nice. So
and later on, definitely the bias detection. Yeah.
We'll hear about that next year.
Sure.
Or our next conference might not be a year from now.
Sure thing. Yeah.
I think Deepak is struggling here, but I want to give him a chance to say something before we close down.
Yeah, sorry, my screen froze up. So thanks for covering that, Vijay. So I think Vijay covered most of the infrastructural parts. Nothing much to add there.
So you could hear us even though we couldn't hear and see you.
Right. Yeah.
Great. Okay, thank you both. And go enjoy the rest of the conference.
Thanks for attending, everyone.